All right, good afternoon. Today we are going to identify solutions of quadratic equations using the quadratic formula. Okay, this is the last and final method that we use to solve quadratic equations. Okay, so the quadratic formula is this very tedious formula in which we need to plug in b, a, and c, or a, b, and c from each quadratic equation and solve, so therefore we can get the x. The benefit of having the quadratic formula is that you can use it for any quadratic equation, whereas when factoring with completing the square root method, you can only use it for certain ones. The quadratic formula, you can use it for all of them, and we will see that as we practice and move on forward. But for today, let's focus on just the quadratic formula and how to use it and the steps. So it says here in order to use the quadratic formula, you want to make sure the equation is set equal to 0 and written in standard form. This one is set already, as you guys can see right there. X squared minus 5x minus 36, that is standard form, and it is equal to 0. All right. Now next it says to identify a, b, and c. Remember, these are the coefficients of the terms. In this case, a equals 1, because x squared has it hidden 1. B equals negative 5, and C equals negative 36. Now that we have identified A, B, and C, we're going to substitute these values into the formula. So notice how we're going to do this. Negative B is going to be replaced by negative 5. A is replaced by 1. And C is replaced by negative 36. So hopefully the different colors will let you see how they're substituted. And there we go. Notice how we do negative 5 plus or minus the radical or square root of negative 5 squared minus 4 times 1 times negative 36 over 2 times 1. Pause here if you need to write that down and think it through. All right, so now that you have it written down, it's all about solving. You want to solve the inside first, okay? Or think about this, about 3 separate problems that you're going to solve for. You want to solve the inside, the outside, and the denominator. So the inside, it comes out to be 25. Negative 5 squared is 25. And then negative 4 times negative 36 comes to be 144. Notice how the negative times the negative became a positive 5 at the beginning. So we have 5 plus or minus the radical sign, 25 plus 144 divided by 2. Right? Pause it here if you need to see how we got those answers. Listen back if you need to. All right, now that we have solved, we have gone ahead and simplify this, we continue to simplify. Add the inside of the radical together. That gives me 169. 5, so now we have 5 plus or minus radical 169 divided by 2. And then you want to check, is this a perfect square or can I simplify that further? In this case, we can because the square root of 169 happens to be 13. Okay? Now that we have this here, then we can do simple math. 5 plus 13 and 5 minus 13. And then divided by 2. Well, 5 plus 13 is 18. 18 divided by 2 is going to give us 9. 5 minus 13 is negative 8. And negative 8 divided by 2 is going to give us negative 4. So my solution is 9, negative 4, and 9, or 9 and negative 4. So the rest of the slides are just simply going to be examples. Here's example 1. Remember that the first step is to set this equal to 0. This is not equal to 0, so I must subtract 20 from both sides. That'll give me 0 now on the other side. Now, negative 20, you cannot add it to anything, so we just got to rewrite it as x squared minus 8x minus 20. And there we go. Okay. Now that it's set equal to 0, we can plug it into the quadratic formula. Let's identify what A, B, and C are. A in this particular problem is 1. B is -8. And C is -20. Okay? Using the colors again so you can go ahead and plug them in. So here how it is when you plug it in. You get negative parentheses -8 plus or minus the square root of -8 squared minus 4 times 1 times -20 over 2 times 1. Pause it here if you need to copy this down. Okay, so once you have it all plugged in correctly, that's always going to be the hardest thing. Remember, simplify this as 3 separate cases. Negative times a negative is going to be an 8, so negative times a -8 will be +8. The inside, you get -8 squared, that's 64. And then -4 times 1 times -20 will give you a positive number of 80, so we get 64 plus 80, and then 2 times 1 is 2. And there we go. Pause here if you need to. Then we continue now by adding the inside of the radical sign. 64 plus 80 will give us 144. Next step is, hey, can I simplify this? Is this a perfect square number? We find out that it is. It happens to be 12, so I can simplify that. Now I do 8 plus 12 divided by 2, and 8 minus 12 divided by 2. 8 plus 12 is 20. 20 divided by 2 is 10, so x equals 10. 8 minus 12 is -4. -4 divided by 2 is -2. Let's look at example 2. Is this set to 0? Yes, it is, so no need to rearrange anything. Time to identify A, B, and C. A equals 1. What does B equal? 6. What does C equal? 10. Let's plug it in. Pause here if you need to copy this down or to understand how that was plugged in. Now let's simplify. The negative times 6, -1 times 6 will be a -6. The inside we get 36, that's -6 squared, and then we get 40. -4 times 1 times 10 divided by 2. Pause here if you need to. Next thing we need to do is 36 minus 40, and we get a -4 underneath the radical sign. Now you got to go back to think about square root methods. What happens if we have a negative underneath the square root? Well, you can't square root a negative number. So whenever you have a negative underneath the square root, we get a solution of no solution. We cannot have any negatives underneath the square root sign. Third example. Once again, this is already set to 0, so we don't need to do anything with that. Identify your A, B, and C. A equals 1. B equals 4. C equals 1. Let's plug them in. And there we go. Pause here so you can understand this or plug it in. All right, continuing here. Now we solve the 3 separate sections. We get -4, we get 16, that's -4 squared, and then -4 times 1 is 4. And we're going to divide that by 2. Pause here if you need to. All right, now we need to do the inside. 16 minus 4 comes out to be radical 12. Okay? Now, we got to check, is this a perfect square number? And we see that it is not. But we can simplify radical 12 because 12 does have a factor that is a perfect square, which happens to be 4. So we're going to factor that, well, square root of 4 is 2. So radical 12 simplifies to 2 radical 3. Okay? Pause here if you need to. Last step to do is, can we still simplify this? Well, we can still divide negative 4 by 2. What is negative 4 divided by 2? That will give us negative 2 plus or minus. We cannot divide 3 by 2. We can't divide radical 3 by 2. But we can still divide 2 divided by 2. In this case, gives us 1. So 1 radical 3. Now, of course, you don't need to put the 1 there. So you can write it as just radical 3. So x equals negative 2 plus or minus, or positive or negative, radical 3. All right, the rest of these examples are extra examples. You do not have to do them, but if you want to, you can. The key word for this PowerPoint is lollipop. All right, so what do you need to do first here? That's right, you got to set it equal to 0. You would subtract 12. That gives us 2x squared plus 7x minus 9 equals 0. Okay, pause here, try to see if you can work it out all the way, and then once you're ready to see if you got the right answer, you can continue with the video. Okay, so once you've worked it all out, your final answer should be negative 9/2 and 1. Yes, you can get fractions as answers, okay? Leave it as a fraction, don't change it to decimals. Here's another example that you can do. Now for this one, it's already set to 0, so we don't have to do anything with that. Your A is 3, but what's your B? Notice there's no x term, so B would be 0. So when you go to plug this into your quadratic equation or quadratic formula, you need to plug in 0 for B. And yes, that just means you get 0 plus or minus, and then whatever is inside, okay? Go ahead and solve for it. Pause it here. Try to see if you can get your answer and see if you get the same answer. And then click forward to see if you get the same answer. All right, so the answer for this one would be negative 2 and 2. All right, this is the last example. See how you do. It's already set equal to 0, so nothing to do there. A here is going to equal negative 1. That's right, because of the front. B equals negative 2. C equals 7. Okay, so plug those numbers into your quadratic formula. Pause the video. And then check if you get this right answer. All right, so once you plug this into quadratic formula, your answer should be negative 1 plus or minus 2 radical 2. This would be an irrational solution. So just to give you an idea of what we mean by projectile motion, we are talking about an object being thrown up in the air. And as you know, when you throw something up in the air, eventually it's going to stop moving and it's going to come back down and hit the ground. So the parabola kind of shows us that in the time frame in which something will be thrown off the object. For example, if you look at this parabola, at 0 seconds, it is a height of 50, at a height of 50 feet. Let's say they're feet. Well, that means maybe you're throwing it off. You're throwing a ball out from the top of a building. When you throw it up in the air, you're going to hit a maximum of 200 feet at around 3 seconds. But eventually that ball is going to start dropping, and at almost close to 7 seconds, that ball is going to hit the ground, which would be 0 height. So that's what we're talking about when we talk about projectile motion. Something to notice about projectile motion is that the y is not replaced by the height. So you're going to see h instead of y. Also, the x is replaced by a t because the x-axis has to do with time. Therefore, when we think about the vertex and projectile motion, you got to think about the time and the height. In this case, maybe something like 3.1 comma height of 200. That would be the vertex. Other things they might ask for is the maximum height. If they ever ask for the maximum height, they're really asking for the h value of the vertex. Remember, maximum, a feature of the graph is the highest range value. And if you notice in the center of the parabola, that is the way you will see projectile motion equations. Instead of seeing an x and a y, you will see h equals. And notice how we have negative 16t squared and 45t replacing the x. And another type of question that you will see is, what is the time at which something hits the ground? Well, they're asking for the solution, they're asking for the x-intercept whenever the height is 0. Okay, so here, these are just some basic things to understand what they mean when they're asking for a projectile motion problem. So let's get into an example. An apple is launched directly upward at 64 feet per second from an 80-foot tall platform. The equation for this apple's height, h, at time t seconds after launch is h equals negative 16t squared plus 64t plus 80. And it asks you to find the maximum height of the apple and how many seconds it will take for the apple to reach the ground. Well, if you see that it's asking for maximum height, then we need to know that they're asking for the h value of the vertex. Okay, we're trying to solve for the vertex basically. Well, if you remember back when we learned how to solve for the vertex, we used a little formula called negative b over 2a. That will at least give us the t of the vertex. Okay. So in this particular problem, remember that a is their coefficient with the t squared, and b is the coefficient with the t. So we're going to replace these numbers. We're going to get negative 64, there's my negative b, and then 2 times negative 16. Okay? And now we just want to solve. Well, 2 times negative 16 happens to be 32, and negative 64 divided by 32 comes out to be t. So the maximum height happens at 2 seconds, but we still don't know the maximum height. Therefore, we will go ahead and plug it into our t. So we're going to get negative 16 times 2 squared plus 64 times 2 plus 80. Hopefully the color code makes it clear that you're just plugging this into the equation given. Then you just solve. Negative 16. Remember to do 2 squared first and then multiply times negative 16. When you put it all together, you will get 144. That is our maximum height. Therefore, that will go up here. So we have solved for the maximum height, which happens at 2 seconds, and the maximum height is 144. Now it's asking how many seconds will it take for the apple to reach the ground. Well, what did I say at the first slide? That h will need to equal when you're looking for something hitting the ground. That means our height is 0. Well, when our height is 0, that means we can use the quadratic formula to solve for our x, because we're really solving for our t. We're solving for our x-intercept. Okay, and so we can use the quadratic formula. So here's how you would do this. Here's the quadratic formula, in case you don't haven't memorized yet. And now we're going to plug in a, b, and c. Pause the video if you need to copy this down. Okay, there's my b. So negative 64 plus or minus the square root of 64 squared minus 4 times negative 16 times 80. Now it's just a matter of doing math. Remember, you want to do the inside first. You can also multiply the bottom. Carry that negative sign. There's negative 64 plus or minus radical 92 16. Check to see if that is it's a perfect square. When you do that, you do find that it's actually the square is a perfect square of 96. Now we do the math. Negative 16 plus 96, negative 64 minus 96, and then divide both by negative 32. And you're going to get two solutions. We get a negative 1 and 5. But think about this. If this is a real life situation, do we ever have a negative seconds? Do we ever have negative time? The answer is no. So then, how many seconds will it take for the apple to hit the ground? It takes 5 seconds. And that makes sense. If at 2 seconds is already at the maximum height, we know it's dropping. Okay, therefore, it would be at 5 seconds when it would hit the ground.